Golden Iris Productions presents an electromagnetic vacuum construction of the gravitational constant, Deriving Emergent Gravity, by Mark F. Dennis.
Abstract. This work presents a stepwise electromagnetic vacuum construction that numerically reproduces the Newtonian gravitational constant, denoted by G. Starting from Coulomb's constant, K, which is 1 over 4 pi times epsilon naught, the Planck length, and the fine structure constant, yields the exact expression for G. The final form explicitly recovers G equals the Planck length squared multiplied by c cubed divided by h bar.
Introduction. The gravitational constant, G, appears in Newtonian gravity and Einstein's field equations. Electromagnetic vacuum constants, epsilon naught, mu naught, q, and the speed of light c, are tightly linked by Maxwell's theory. The Planck length, denoted by L sub p, equals the square root of h bar times g divided by c cubed. This connects gravity with quantum mechanics. We present a structured algebraic sequence, beginning with the Coulomb constant and ending with the Planck form expression for G.
Starting with Coulomb's law. Coulomb's law describes the electrostatic force between two charges. F equals K times Q1 times Q2 divided by R squared. This inverse square form mirrors Newton's law of universal gravitation. F equals G times m1 times m2 divided by R squared. Both laws share the same mathematical structure, differing only in their coupling constants.
Step 1. Coulomb's constant. We begin with Coulomb's constant, K. K equals 1 divided by 4 pi epsilon naught, which equals approximately 3.89428 times 10 to the minus 10. This establishes the algebraic starting point.
Step 2. Multiply by 4 pi epsilon naught. We then invert the constant. 4 pi epsilon naught equals approximately 8.987551788 times 10 to the 9th. This results in a very large value. Step 3. Divide by q squared, with r squared equals 1 meter squared. From Coulomb's law, we introduce the electric charge q, equivalent to E, and set the distance r squared to 1 meter squared. Then we have 4 pi epsilon naught divided by q squared equals approximately 4.33449 times 10 to the 27. A small charge produces a large amplification. Step 4. Maxwell identity. The speed of light, c, is now introduced from Maxwell's equations. C squared equals 1 divided by epsilon naught times mu naught, which implies that epsilon naught equals 1 divided by mu naught times c squared. Then 4 pi divided by mu naught times c squared times q squared equals approximately 4.33449 times 10 to the 27. Relativistic scaling enters via c squared. Step 5. Alternate electromagnetic form. Then multiply both sides by c to the 4th power. 4 pi times c squared divided by mu naught times q squared equals approximately 3.50123 times 10 to the 61. This brings c squared into the numerator. Step 6. Vacuum-only form. Convert c squared back into epsilon naught and mu naught. C squared equals 1 divided by epsilon naught times mu naught, which implies 4 pi divided by epsilon naught times mu naught squared times q squared equals approximately 3.50123 times 10 to the 61, now expressed purely in vacuum constants. Step 7. Introduce Planck area. By squaring the Planck length, we scale the system to Planck units, transforming extremely large numbers into standard values. 4 pi times L sub p squared divided by epsilon naught times mu naught squared times q squared equals approximately 9.14619 times 10 to the minus 9. Planck-scale bridges electromagnetism and gravity. Step 8. Fine structure constant. We now multiply by alpha, the fine structure constant, approximately 1/137. G equals 4 pi times L sub p squared times alpha divided by epsilon naught times mu naught squared times q squared, which equals approximately 6.6743 times 10 to the minus 11 in units of meters cubed per kilogram per second squared. We have now derived G from Coulomb's law. Final identity. Insert the expression for alpha. Alpha equals q squared divided by 4 pi epsilon naught times h bar times c. Then G equals L sub p squared divided by epsilon naught squared times mu naught squared times h bar times c. Using c squared equals 1 divided by epsilon naught times mu naught, we get G equals L sub p squared times c cubed divided by h bar, which implies L sub p equals the square root of h bar times g divided by c cubed. Conclusion. Starting from Coulomb's law and the electron charge, we systematically incorporated the vacuum constants, epsilon naught, mu naught, and the speed of light, c. Through this algebraic sequence, we established a numerical bridge from the electromagnetic domain to gravitational phenomena. By introducing the Planck length squared, we scaled the extremely large electromagnetic derived values down to standard units, providing a natural connection between quantum scale physics and macroscopic gravitational effects. Multiplying by the fine structure constant alpha allowed us to recover the gravitational constant numerically. G equals 6.6743 times 10 to the minus 11 in meters cubed per kilogram per second squared. This demonstrates that Newton's universal law of gravitation can emerge from Coulomb's law through vacuum and Planck-scale physics. This result highlights the deep interplay between electromagnetism, quantum mechanics, and gravity, suggesting that G is not an isolated constant, but an emergent property of underlying electromagnetic and vacuum structures. By tracing the chain from Coulomb's law through vacuum constants, the speed of light, Planck-scale geometry, and the fine structure constant, we have shown that Newton's gravitational constant G emerges naturally from electromagnetic principles. The same inverse square form that governs electrostatics can, when combined with the fabric of the vacuum and quantum scaling, reproduce the strength of gravity itself. This remarkable connection hints at a deeper unity between electromagnetism, quantum mechanics, and gravity, a glimpse into a world where the fundamental forces may be intimately intertwined. With this understanding, we may be able to engineer gravity, manipulate its effects, or even nullify inertia, opening doors to revolutionary technologies and new realms of physics. The discovery that G can be derived from electromagnetic and vacuum constants transforms our perspective on the origin of gravitational phenomena. To be continued.